Hi guys, my name's Ian. This week I'm back with lesson number 18 in Paul McWhorter's Arduino with Python series. We've got a 3D Pong game going, and let's have a look at some code. There's been action this week in both the Arduino and the Python code. The Arduino code is almost the same as last week, but let's have a look at a few differences. First thing I'm sure you've already spotted is we've got a wee bit of this going on, and this. What that's associated with is some testing. We're testing our lights on our buzzer as we start. That will be in the setup loop. The most important change this week has been in our jobs. Alright, so we've got a read command job. Now, we've got some client-server action happening this week. Basically what that's about is, last week, once the Arduino started, it was sending the joystick data as soon as it started and forever afterwards. This week, the client-server action is the Arduino only sends the joystick data when told to do so, and until it's told not to do so. So there's commands coming from the Python saying send the data, commands from the Python saying stop sending the data, and that works in with the gameplay loop. So while we're sitting waiting to start a game, there's no point sending any data. So that's the idea, but it's client server action. I'll show you how that's working. As a result, I've collapsed the LED and buzzers jobs into one job. The other action job is whenever it does receive a send and stop data command from Python, it sets some flags. So let's have a scoot down. This is the simple testing of the LEDs. Turns them all on, turns them off. And then the buzzer, you'll notice that there's an M there. That's because the buzzer now has three notes, a low, a medium and a high. Why not? So, into a quick look at the command for receiving these, the job for receiving these commands. So you see there's three commands now. That's the get sensor data, and that can be a 0 or a 1. And then there's the LEDs and the beep, which are this similar to last week. The LEDs is a number between 0 and 7 for whichever binary pattern we want with the LEDs. And the beep is now a low, a medium or a high, followed by the duration. That's not too difficult. If you want to have a look at that code, that's it there. So low, medium and high. And I just picked the middle between low and high to be a medium. There we go. Anyway, let's see this code in action when it starts up. So if we jump to this next screen to look at the hardware, what you can see is everything as before with last week. LEDs, buzzer, this is my Arduino Nano on the little carrier, and the joystick. So if I connect to it with the excellent CoolTerm, you will see it start up. You will see the LEDs on the buzzer. So there we go. It started up. No data is coming out until I send the command to tell it to start, in which case if I send that, so it's get sensor data equals 1. There we go. We've got the data. Now if I quickly do a 0, we can see that the data stops. Excellent. Now, other commands still work, of course, so we can do LEDs equals 5. There we go. Send that. How about that? And if we go LEDs equals 1, on back to 0, easy. And if we do a beep, beep equals, let's do a high for half a second. Don't know if you heard that. Maybe you did, but I did. Anyway, there we go. Perfect. Let's have a look at some of the Python code now. So I'll disconnect this because it will only trip up the Python later. And when I find when I disconnect Cool Term, it actually causes the Arduino to reset as well. So you'll see that all happen again. There we go. So it's sitting now waiting for commands again, although I'm not going to be sending any. So let's have a look at the Python code now, and if I turn off the Arduino screen, there we go. How about that? So the Python code is largely the same, except for a little bit which I'm going to show you. So we've got some variables I set up for starting and stopping the data. You'll see that in use later. The cell drawing code is the same, except my arena is a little bit small this time. I didn't want to have 7 boxes. I've now got 5. I've cut out a couple of middle ones. Does the same sort of thing, just smaller. You'll see that later on anyway. This is an interesting bit. This is my send the code, the command to Arduino. It's the same code that was in the while loop last week, except because I'm using it more than once, didn't want the repetition, so I made it into a function. You'll see that in use later. As I say, we're having less rooms, only 5. Still got a couple of bats. We've got a ball. We've got some more messages now. You'll see that in a moment. Interesting thing about this is last week I was using the opacity to control turning a message on and off. Well, that's not the best. When you had it opacity of 0, invisible, all it did was turn the letters or the words to the background color. But if you tilted the box and happened to move the box in front of those, or well, behind those letters, you could still sort of see the shadow of them. A better way to control it is with the visible command. Completely turns it on and off just by setting this to be true or false. So I'm using that instead of opacity. Anyway, let's go down and have a quick look at this. There's a wee bit of gameplay going on. We now have a notion of lives and a hit counter, and this is where we're controlling these messages being turned on and off, being visible or not. And then this is in the first use of that send Arduino function, where this is where it basically, after it's got itself going and drawn the arena, it tells the Arduino to send data. Now, I scooted past it quite quick. You might not have spotted this. I had a bit of a problem. I ended up running this code and it sat there looking at me, drew me the arena, and nothing happened. What I eventually found out was that I was stuck in basically a wait. The Arduino had taken longer than what it was last week. It was a 1 second. The Arduino had taken longer than 1 second to start up. The Python code, being much quicker than the Arduino, had got to the point where it had sent the command to tell the Arduino to send the data. At that point, when the Python code sent it, the Arduino hadn't started up, it wasn't ready, so it missed that command. Eventually the Arduino was sitting waiting on this command, which was never going to come, and the Python code was sitting in this loop waiting for the data, which was never going to come. Once I eventually worked out, I had this, I don't want to, maybe it's a race, I don't know. Either way, both of them lost. It came to a sharp focus when I added in the extra bits where the Arduino blinks the lights and does the buzzer. And then it occurred to me what was going on, and I found that increasing the time sleep after starting the serial port to 2 seconds is enough to make it work. Anyway, back to where we were. We send the start the data command to the Arduino. It starts sending the joystick data over, and then everything happens as it did last week. We're watching for, doing our zone checking. There's fewer zones, so there's less of this code. There's less of this code here. The next interesting bit is down here, where we're discovering, is the ball leaving the arena, either through zone 1 or zone 4, either of the open ends. This is where we're doing our checks. Is the bat going to hit it? Have I put the bat in the right place? If so, then we up the hit counter and do things like, you know, increasing the difficulty game with the bat getting a little smaller, etc. If we haven't hit the ball, this is where we lose lose a life. Now we start off with 3. That's set in a variable outside the while true loop. But basically, if you miss the ball, you lose a life. Assuming you haven't ran out of lives, then basically this variable gets set to true. Now, if we have run out of lives, it's game over gets set to true, and then some messages are turned on about the game over visible. I'll show you what they look like in a moment. I've got some screenshots of that. And then we've got the usual bounce checking for the ball being bounced or not. Now into the sending commands back to the real world. Again, we're constructing a command. We've got different sorts depending upon whether it was a miss, just a bounce, a zone location change, and then we send whatever command it is we've constructed for whatever situation it happens to be. Game over, ball miss. Well, game over will help us select this or that. But within, assuming the game isn't over, we've got a ball miss, we've got a ball bounce, or we've got a location change. Right. And then we send the command. Excellent. Assuming the game isn't over and we haven't dropped out of this this double while loop entirely, well, out of the inner one, this while loop here, the while not game over. So if we've dropped out of that, we end up down here, where basically then we tell the Arduino to stop sending the data. Excellent. Now this is just a variable. If you look up top, you'll see that's a 0. The one to send the data is a 1, but it just makes more sense to put as a variable, because then you can read what it's trying to do. It then turns off some of these gameplay messages, which is, you know, the name of the game, the lives counter, the hit counter, and it displays your final score. Turns that on instead. And then sits waiting. Shall we play again, sir? Assuming you don't kill the program or anything like that, you press return, and then we clear off the game over messages, reset the bats. I'm still doing this because I think that's a good idea. I'm still resetting the buffer just in case there's anything in there, and then we play the game again. So let's have a quick look at what the game looks like. So let's find another screen. Let's find this demo screen for you. Here we go. So there you have it. That's what the game looks like when it's playing. You've got the ball, you've got a bat, you've got the name of the game, and you've got a lives label and a hits label. At the end of the game, you get something that looks like that. So the ball's turned red and you get different messages and a score in the middle. And then if you start the game again, you'll be back to something like that. Super stuff. Let's have a look at the game in action. So if I go to this screen and then tell the Python to start running, let's see what we get. Hopefully soon. Here we go. At long last. So you'll see that once it opens the serial port, it'll reset the Arduino. The lights will beep, etc. There we go. Well, the lights won't beep, they'll flash, and the beeper will beep. And now the game is in play. So I can move. I can change. The ball's going very slow. Still a random change vector for that. It might give me a chance to hit it. Oh goodness. Here we go. Here we are. I'm going to get that there we go, I hit it, and you can see I had a hit counter increase there. And I'm hoping you're hearing all these beeps, and you're seeing that the lights are changing as usual when it goes into a different zone. So that's my 3D Pong game. Now this ball's coming back to me. Let's come on, I can hit it again. Actually, let's miss it and you'll see the lives go down. So I'm going to miss it. There you go. I missed it. I lost a life. And that's the way the game goes. All the code, as usual, will be on GitHub. I've not sure where this is going next, because I don't think the series is going to last much longer with Paul. I think he's approaching an end to it. But what I have noticed in this, and this will shock you, but the Arduino code doesn't work. There's a piece of it doesn't work. So if I just let that game play with itself and jump back to the software, let me show you something which I discovered in my more in-depth testing. I introduced the watchdog. Oh, let me make sure you can see it, because you can't at the moment. There we go. Right. Some weeks ago, I introduced a watchdog. Now, as it so happens, in the last few weeks, oh, the game's just finished. In the last few weeks, I was testing the watchdog. You know, how did it work? What happened? And as it happens, it didn't work, and not a lot happened. Of course, I was absolutely shocked with that. I mean, how could such a state of affairs exist in my code? And so I thought maybe this library wasn't very good. So I recoded with another library. It was, I think, an Adafruit library. Redid this code a little bit and ran the same test, and it failed. Interestingly, it failed in exactly the same way as this library from Peter Polidoro. So next thing I decided to do was, well, I'll use one of the example codes that comes with the library, and it didn't work either. It failed in exactly the same way as my code failed. Now what it was doing was, it was detecting the watchdog was kicking in whenever I constructed the code to make sure it did, because I could tell that because the heartbeat light that is merrily blinking, and let's show you that, the heartbeat light that is merrily blinking, well, it stopped blinking. In fact, it stopped blinking at my rate of 1/2 hertz or whatever. It actually then started blinking mega fast, really fast, and it did that with the example codes from both the other watchdog libraries and when I failed the watchdog of my own library and my own code. Some testing later and some researching it, I discovered that the issue is actually not with my code or with the libraries. The issue is with the Arduino Nano. Turns out that mine, because I haven't had any need to change it, are running what's known as the old bootloader. So clearly there's an old one, I'm using it, so there's also a new one. The old bootloader is, I think, something called Megaboot, which is from the Atmel people, the people who make the chips that are the heart of the Arduino. The new bootloader is what they call the OptiBoot, and I think that's from the Arduino people themselves. But nonetheless, the difference is that there's a bug in the old bootloader, which means that the watchdog reset doesn't work right. So the next thing I have to do to fix this is called a bootloader update. You need to use 2 Arduinos to do that, and some wires between them, some code that's all freely available, and then you send over the new bootloader, this OptiBoot, and then hopefully I'll fix it. So that's what I'll be doing next. Anyway, any comments, questions, leave them down below, and hope you have a great day.